Hello and welcome. So we'll be solving the question above. We are to calculate the reaction at A and D, and we are to draw the bending moment and the shear force diagram, of which I've already replaced this support with reaction at A and this support with reaction at D. Alright, so the first thing we'll be doing here is, if you look at this beam, there is something like a pipe here, which is at a distance of 0.5, and then we have a downward force acting here, which is 4 kilonewton. All right, so now if you know moment is force times distance, right? This force, if you use it to multiply this distance of 0.5, you are going to have 2, and you are going to notice that the downward force here is producing an anti-clockwise moment, not clockwise this time around. Is that clear? I told us it depends on what? On the distance or the direction. Do you understand? So now if you look at this moment now, it's giving us what? Anti-clockwise moment. So if you multiply 4 by 0.5, you are going to get 2. So we are going to replace this pipe now with an anti-clockwise moment with this downward force. So that's what we are going to be doing. So we are going to clean this pipe. So we have replaced this particular place with anti-clockwise moment and with a downward force. All right. So again, here, if you look at what we have here, if we resolve this angle into x and y direction, resolve it into x and y direction. So our y, which is this place, don't forget that this place will be 90 degrees. So this place is going to be opposite over what? Hypotenuse. That is, this unknown sine 30 will be equals to this unknown over what? This 4. So that is 4 sine 30. This place is going to be 4 sine 30, which is what? 2. And this place is going to be unknown all over what? This. That is cos 30. That is 4 cos 30. That is going to give us what? 2 root 3. Alright. So now if you look at this carefully, if I carefully trace this line, and I trace this part. Sorry. All right. So here you will observe that we have this force coming in this direction and this one going in this direction. So here we are going to have 2 here. We're having our 2 kilonewton here, and here we are going to be having 2 root 3 kilonewton. All right, we write this very well. All right, so that's it. All right, so now the next thing we are going to be doing is we are going to be calculating, we are going to be taking the sum of our horizontal forces. So the sum of horizontal forces is equals to what? 0. And if you look at this diagram very well, our horizontal force here is going in this direction, while this one is coming in this direction. So let's take our direction. Let's take this one that is going towards that direction to be positive. So it shows that I'm going to have arrow d subscript h to be equals to 2 root 3. So that is just all. All right. So now the next thing is the summation of forces in the y direction will be equals to 0. So here we are going to be taking upward force to be positive and downward force to be negative. So the summation of upward force is arrow a plus arrow d here. So we are going to have arrow subscript a plus arrow subscript d will be equals to all our downward forces. So the first downward force here is 2, then plus what? Plus 4, then plus, if you convert this uniform distributed load to a point load, it's going to be 1 times 2. So this is going to be what? 2. So here we are going to have arrow subscript a plus arrow subscript d to be equals to 8. So we'll call this equation number 1. All right. So we are going to be taking our moment about what? about point A. So we are going to say summation of moment about point A is equals to what? 0. Alright. So now if we stand at this point, and here now, if you look at this place now, if you stand at this point, you are taking your moment about this point. So if you want to start with this, you are going to have arrow D, and then it's going to be coming towards this direction. That is anti what? Anti-clockwise. Is that clear? Alright, again, and we know that this moment too is going what? Anti-clockwise. So you can take your moment here, because you know, here we said upward force positive, downward force is what? Negative. So our upward force here is going to be giving us a positive moment, while our downward force here is going to be giving us a negative moment. So that is just it. When you say upward force positive, just stand at that point, about point A, and if you look at this, this is going what? Anti-clockwise direction. So you are trying to say your upward force is positive. It means your anti-clockwise moment is positive. All right. So it means that we start with this. We are going to have arrow subscript D multiplied by the distance that it covers. That is 6. We are going to have 6 plus what? Plus 2. This moment here, which is going to be. Then if you look at this other force, we have 2 multiplied by the total distance. That is 7, right? That is going to be minus 2 multiplied by what? 7. And here we have 4 multiplied by what? Multiplied by 4. Minus 4 multiplied by 4. Why this part, when we convert this to a point load, is going to be what? 2. And it's going to act at what? At 1 meter to the right and 1 meter to the what? To the left. So we are going to have this to be minus 2 multiplied by 1. Everything should be equals to what? 0. Alright, so this is going to be 6 arrow subscript D plus 2. Then this is going to be minus 14 minus 16 minus 2 equals to what? 0. So these 2 will cancel out these 2 here. Then we are going to be having 6 arrow subscript D to be equals to minus 14 minus 16, that is minus 30. If you take it to this side, I'm going to have it to be what? 30. So if we divide both sides by 6, so arrow subscript D will be equals to what? 5 kilonewton. Alright. So now, from our equation 1, we already said arrow A plus arrow D should be equals to 5. It means arrow A will be equals to 8 minus what? 8 minus arrow D. But our arrow D is what? 5. So it means that our arrow A is going to be 8. Is going to be 8 minus 5, which is 3 kilonewton. So that is the reaction at A and D. So we are done with the first question. So we want to go for our shear force calculation now. So let's go for our shear force. Alright, our shear force calculation. So we'll be starting with the shear force at point E. Shear force at point E. Alright, our shear force at point E. We stand at point E to the right. We are going to observe that we don't have any force. But the only force that we only have here is just this 2 kilonewton that is acting downward. And again, here we are still maintaining upward force positive, downward force negative. So we are going to have minus 2 kilonewton. Alright. So at point D, shear force at point D will be equals to, now if you stand at point D, to your right, we have 1 and 2. So this is minus 2 plus our arrow D. Our arrow D is what? 5. So this is going to be what? 3 kilonewton. So the next one is the shear force at point what? At point C. So this will be equals to, so if you stand at point C, you are going to have minus 2 minus 2 plus 5 then minus 4 will be equal to what? So you are going to have this to be equals to minus 6 plus 5, that is minus 1. So this will be minus 1 kilonewton. Alright, so if you stand at point B, shear force at point B will be equals to, so we start at point B, the shear force at point B will be the same as the shear force at point C. That is going to be -1 kilonewton. Alright, so if you start at point C now, point A, so the shear force at point A will be equals to, so if you stand at point A, you stand at point A, so you are going to have this to be giving us -2 plus 5, then -4, then our arrow A there, downward, upward is what? 3, right? So plus 3. So that will be equals to what? So here we have -2 minus 4, that is -6, plus 8, that is 8 minus 6. So that is going to give us what? 2, right? Alright. Sorry, there is a little error here. When we stand at point A here, we already know we will have this. But if you look at this, there's a uniform distributed load here, which we convert to a point load. So that is going to be 1 times 2. Please, not this arrow here. So 1 times 2 is 2, and it's going to be acting downward. So it's going to be -2. Sorry, please. So I was standing here, I was looking at other stuff. So we are going to have -2 here. So by the time you do this, you are going to have -2 -6 -8 plus 5, that is -3. So we are going to have here to be -3. Alright, so that is going to be our shear force. So the next one is our bending moment diagram. Bending moment calculation. Alright, so we'll be starting with the bend moment at point E. Alright, if you stand at point E, we only have this downward force here, but to our right, we don't have distance. Don't forget, don't go and use 2√3 as distance. 2√3 is not distance. 2√3 is our horizontal force. You understand? We don't have any distance. So the bend moment at point E is going to be what? 0. Alright, so let's go for the bend moment at point D. Bending moment at point D. So if we stand at point D and you take your moment, so we are going to have -2 multiplied by 1. So -2 multiplied by 1, which is -2 kilonewton meter. Alright. So if you stand at point C, C, bending moment at point C will be equals to, we start at point C, we have 2 moments at point C, so you have to be careful. So the first one is -2 multiplied by what? 3 plus ROD multiplied by what? 2. So -2 multiplied by 3. Then ROD, our ROD is 5 plus 5 multiplied by what? Multiplied by 2. So if you do this, what do you have? That is -6 plus 10. That is what? That is 4. So by the time you now add this anti-clockwise now, you add the effect here now. That is, we are adding it because anti-clockwise moment is giving us is positive based on our assumption here, based on our coordinates. So now this is going to be +2. So if you add the effect to this 4, you are going to have it to be 6 kilonewton meter. Alright. So the bending moment at point B now. Alright, if you stand at point B, we are going to have -2 multiplied by total distance, which is 5. So plus ROD multiplied by total distance, which is 4. And we are now going to add this moment again. So let's do that. We are going to have -2 multiplied by 5, right? Plus ROD. Our ROD is 5 times 4. right? So again, 4 times minus 4 times 2 minus 4 times 2. Then we have another anti-clockwise moment there plus what? Plus 2. So this will be equals to, all right, this is minus 10 plus 20, that is 10. And 10 minus 8, that is 2. And 2 plus 2, that is what? 4. So we have this to be what? 4 kilonewton meter. All right. So the bending moment at point A is going to be what? 0. The bending moment at point A. All right. Bending moment at point A. If you do this, I think this is supposed to give us 0. That is, if you take your 2 times the total distance, you are going to have this to be 2 times minus 2 times 7. Okay, let's just do it. We're going to have minus 2 times 7. All right, minus 2 times 7, then plus ROD, which is 5, times ROD is the total distance there is 6. All right, then we have a downward force, that is minus 4 times 4, minus 4 times 4. All right, minus 4 times 4. Then we have this anti-clockwise moment plus 2. All right, then I will now have a uniform distributed load to point A, that is minus 2 times 1. So minus 2 times 1, this will be equals to, so here we have minus 2 times 1 is minus 2 plus 2, that is going to cancel out as 0. So here we have this to be minus 14 minus 16. Minus 14 minus 16 is minus what? 30. And 5 times 6 is 30. Minus 30 plus 30 is what? 0. So this is going to be what? 0. All right. So that's how to go about that. So the next thing we are going to be doing is we are going to be drawing our shear force diagram and our bending moment diagram. So we are going to be tracing every point that we have load downward. So that's what we are going to do next. We are going to draw our reference line now. So for our shear force, we have the highest number there is 3 and positive 3 only. All right. So let's just take this point. So this point is perfect. All right. So we are going to draw our shear force diagram first. All right. So at point E, we have this point to be what? -2. So let's take this point as our -2. And between point E and what? And D, we don't have any load. So we are going to be using a constant line here. All right. So and the shear force at point D is what? 3. So we can call this point our 3. So we're going to join this point down to this point. All right. So and between C and D, we don't have any load again. So we use a constant line. All right. So that's what we have. Now our shear force at point C is -1. So -1 is going to be somewhere around here. All right. So that is it. And then between C and D, we don't have any load again. So we use a constant line. All right. So our shear force at point A is -3. So let's take this point here as our -3. So we'll be using an inclined line because we have a what? A uniformly distributed load. All right. So this is what we are going to have. So this is going to be a what? A negative side. This is going to be a positive side. This is going to be a negative side. All right. So we can shade now. All right, so that is what we have. Now, so the next one is our bending moment diagram. So let's draw the reference line for our bending moment. All right. So our bending moment, we have -2, we have 4, and then, okay. All right. So that's what we have. All right. So our bending moment at point E is 0. And the bending moment at point D is -2. So let's call this point, last point here, our -2. So let's call this last point here our -2. So we are going to be using an inclined line to join this line. All right. So that's it. All right. So now at point C, we have two moments, right? The first one is what? It's giving us 4. So we are going to go up 4 units. So let's call this point to be our 4. So we are going to join this 4 down to this point. All right. So now again, when we now add the effect of this clockwise moment to that, we now have 6. So let's take our 6 to this point. So we are joining this point to this other point down here, which is already joined. All right, sorry, I was doing everything on point D. Sorry, this should be on point C. All right, so let's take it again. The bending moment at point C is 4, right? So we are going to have our 4 at this side. All right, we have our 4 at this side, right? All right, so it means that and we say our bending moment at D is -2. This is -2. So we are going to be using an inclined line to join this point to this point. Sorry, please. I was busy doing everything at point D. All right, so when we now add the effect of that here now, we now have 6. So we are moving down to what? 6. So we are joining this point to this point. All right, so that's it. So now at point B, which is this side, the bending moment at point B is 4, right? And don't forget that this point here will be at the same distance with this. So this one too is 4, right? So we'll be using an inclined line. We're using an inclined line. We're using an inclined line. All right. So that's it. So now the next one is bending moment at point A, which is what? 0. So we'll be using a parabolic curve for this. I'm going to be using a curve. All right, so that's it. So this point is positive. This point is what? Negative. So we can therefore shade now. All right, so this is how to go about this question. Stay tuned for more interesting questions. Thanks.